Hello everyone. So today we are going to discuss the problem C of the Codeforces round 990 div 2. Swap columns and find a path. We're given a matrix consisting of two rows and n columns. The rows are numbered from 1 to 2 from top to bottom. The columns are numbered from 1 to n from left to right. So we are given a matrix that looks something like this. So we are given a 2 by n matrix. Each cell contains an integer. Initially, the integer in the cell I, j is aij. You can perform the following operation any number of times, possibly 0. You choose two columns and you swap them. So basically, if you are given a matrix like this, I can choose any two columns, okay, and I can swap them, okay. That's what we are allowed to do. After performing the operations, you have to choose a path from cell 1 comma 1, that is this cell, to the cell 2 comma n, to the end cell. So we have to choose a path from this cell to this cell, and for every cell ij, the path except for the last, the next cell should be I plus 1 comma j or I comma j plus 1. It means that you are only allowed to move forward. You are only allowed to move to the right, okay, or to the down. Once you move down, you're not allowed to move up again. This is a one time move, yeah. You can move down only one time. However, you are allowed to move right until you reach the end cell, okay. Obviously the path cannot go outside of the matrix. Yes, you have to start from 1 comma 1 and go to 2 comma n. Okay, the cost of path is the sum of all the integers in the n plus 1 cells belonging to the path. So we travel n plus 1 cells. So as you can see, there are n cells here, right? As we move along the column, there are n cells, and this is one additional cell that we travel. So there are a total of n plus 1 cells, and the cost is the sum of all the integers that are present in the cells. And you have to perform the operations and choose a path so that the cost is the maximum possible. So we have to swap the columns in such a way that if we choose a path, it will give us the maximum possible cost. And this is here the input format, which is, first of all, it will contain the number of test cases. For every test case, what do we have? We have an integer n that denotes the number of columns that are going to be. And the second line contains the n integers, that is the numbers that are present in the first row. And the third line will contain the numbers that will be present on the second row. For each test case, print one integer, the maximum cost of path you can obtain. So I hope the question is clear. Let's have a look at the test cases. So the first line is the number of test cases, right? So let's focus on the last one, okay? So our matrix looks like this, right? And we are allowed to swap any two columns. So we can swap this and this column. So we can move around, okay? For example, we can swap this with this. So this comes here and this comes here, okay. And let's try and find out the path sum. So for the first case, like the maximum that we can get is, like, we can go till here 2 8 is 10, okay, 10 10 is 20, then it's 23, and then it's 27, right? We can have 27 like this. But is 27 the maximum? Well, our answer says it's 29, right? If you see the output, it is 29. So somehow, swapping it, we should be able to get 29. Let's check out another path. So let's go like this. So 2 and 8 is 10. 10 plus 5 is 15. 15 plus 3 is 18. 18 plus 4 is 22. Again, 27 was our best answer, I guess. So let's move on here, okay? So I basically swapped this 3 4 with the 5 3 column, okay? Again, then we come here. 2 8 is 10. 10 and 8 is 18. 18 plus 4 is 22. 22 plus 3 is 25. So the best we can get from here is 25. So let's give another try. So let's swap the second column with the third one. Now let's try and find out the max path sum. So we can get 2 plus 3 is 5. 5 plus 8 is 13. 13 plus 8 is 21. 21 plus 3 is 24. If we choose this path, 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 10 is 19. And then 23. So 24 is the maximum, I guess, for this particular path. Okay. but still we are not able to get 29, right? Let's try and swap the second one with the fourth one. We're just checking it out, okay? So which swap works, okay? So I can now swap the second one with the fourth one. The second one, put it here, I take it here. Now if we calculate, so 2 plus 5 is 7, okay? 7 plus 8 is 15, 15 plus 10 is 25, 25 plus 4 is 29. So yes, 29 is indeed the answer, okay? It is for sure that you will not be able to find a path that will give you a sum that's greater than 29. Okay. So basically, in your path, you can move like this, right? Okay. Or it could be like straightforward like this, isn't it? But at the end, you have to somewhere come down. Or you can come down at the very beginning and then go like this. So basically, one column has to be traversed completely, right? In all of the cases, we have to traverse one column completely, right? So which column should it be? That is for sure that we need to traverse one column completely, right? Okay. And we have to maximize the path sum. We have to maximize the cost. So let's say there are a bunch of columns that are given to you, okay? There are a bunch of columns. So your path could be like this, right? Your path could be like this. Your path could be like this. Yeah. So basically, once you move down, you can't move above, right? So there's gonna be only one column which you will travel completely, right? We have that in mind. Okay. So let's say this is the column. Okay, this is the guy. Okay. Let's assume that this is the column for which we take both the values. Okay. Okay, and we can swap all these columns, right? I can swap this column with this one and I can change this to this, right? I can do all the swappings, right? Okay, but I know that I'm going to take both of the values for this particular column, right? And I can place that column anywhere in the matrix, okay? And I can play around with all of these, right? I can play around with all of these columns, right? Okay, but this is the one for which we are going to take both the values in our cost, okay? So how should we place the other columns? The question is, how should we place the other columns around this particular column? Well, we are going to travel like this, right? Let's call it the path change column. Okay. So the columns that come to the left of the path change column, we only include the top values of it, right? And the columns that come right of the path change column, we only include the downward values of it, right? We only include the values that is at present at the bottom of the column, and here we include the values that are present at the top of the column, isn't it? So we can say that to the left of path change column, we should be placing those columns whose upper value is bigger than lower value. So for these columns, the values at the top should be bigger than the values at the bottom, right? Okay. And similarly to the right of this path change column, okay, we should be placing those column whose lower value is bigger than the upper value. The lower values for these columns should be bigger than their upper values. So that's how we should place the other columns around our path change column. Okay. So first of all, what we are going to do, because the value of n is less than or equal to 5000, it means our solution could be an O of n squared solution, right? So first of all, we are going to put our path change column. So we're going to iterate from 0 to n minus 1. So since we are going to be moving along the path change column, so there's going to be a path change sum. So this is going to be, so if the jth column is our path change column, if jth column is our path change column, then the sum is going to be matrix of 0, comma j plus the matrix of 1, comma j. And now we're going to talk about the rest of the columns, right? The rest of the columns around our path change column. So have a loop again, okay? For k going from 0 to n minus 1, okay? And if we come across a point that the value of k is equals to j, then we are just going to continue. We're just going to ignore this thing because we are concerned about the columns that are left to the path change column and the columns that are to the right of it. Okay. So remember what we talked about. All the columns that we placed to the left of it have values that are bigger at the top, right? The top values are bigger for these columns, and all the columns that we place towards its right have the bottom values bigger. What is common between the set of right columns and the left columns? Okay, the common thing is that we're adding the maximum of the two values. So we have a path change sum, right? And now we will be adding the maximum of the upper and the lower value for each of the column. So what I said was the common thing between the left columns and the right columns is that we are adding the maximum of the two values of each column to our path change sum. It's just that these columns have values that are bigger in the upper side, and these columns have values that are bigger in the lower side. But we are basically adding the maximum of the two values. So to our path change sum, we are basically adding the maximum of the two values of each column. Now this is when we assume that this jth column is our path change column. And we keep on doing that by keeping every one of them as our path change column, right? So here we can initialize our result with a very big negative number. After the looping gets over, we can keep on updating our result. And that's how we can get our answer. So let's see the real code. So if we look at our code, we start with taking our input and we declare our matrix. We take in the input of the matrix. So till here it is all about taking in the input. We initialize our result with a very huge negative number. We start with the 0th column and we go till the n minus 1th column, and we start with the path change sum. So it's gonna be mat 0 j plus mat 1 of j. So basically we are assuming one of the columns to be the column which is going to be our path change column. So remember, every column to the left of it should have the upper value which is maximum, and every column to the right of it should have the lower value that is maximum. That is how we should place it, right? But we are not placing it. We just have to find out the maximum. What we need to do is we need to add to it the values from each of the columns, okay? And what values we need to add? We need to add the maximum ones. The columns whose upper value is bigger, we will place towards its left, right? And the columns whose upper value is smaller and lower value is bigger, we will place towards its right. That is going to be our strategy. This was our path change column, and this is going to be our path. And finally, we keep on updating our result as the maximum of result, comma, the path change sum, and finally, we output our result. Thank you. Let me know in the comment section if there is any point that's not clear.